Hi, Timothy Unkert here. In this video, we're going to find a solution to a system of equations, and I'm going to go through various different methods to do that. So we have this system of equations 2x plus 3y equals 12, and 3x minus 3y equals 18. And finding the solution means finding where they intersect. So the point xy where they intersect, we're going to find the values of x and y. First technique I'm going to show you is elimination. So right here, what I can see is I have a positive 3y here and a minus 3y here, or negative 3y. If I add these two together, it eliminates the variable y, and we can easily solve for x. Then I can plug x back into either one of these two equations to solve for y. So let's add these together. The 3y's will cancel out, and we'll get 2x plus 3x, which gives us 5x. I'm just going to move it over a little bit. So we get 5x equals 12 plus 18, which is 30. Okay, solve for x, we'll simply divide by 5. 5's on this side will cancel, and we'll get x equals 6. So we're partway there to finding our solution. Our solution is 6, and then whatever the y value is. To figure that out, I can take the x value 6 now and put it back into one of the original equations. So let's just go with the top one. So we're going to do 2 times 6 plus 3 times y equals 12. 2 times 6 is 12, so we have 12 plus 3y equal to 12. Well, here what's going to happen is when I subtract 12 from both sides, we're going to get 3y is equal to 0. If I divide by 3, let's move this over here, I get y is equal to 0, because 0 divided by 3 is 0. So my solution is 6, 0. Okay? And that was the elimination method for solving a system of linear equations. Next, let's look at substitution, but let me erase this stuff first. All right, for substitution, we're going to solve for one of the variables. I'm going to do this bottom one. I think it lends itself a little bit better. I'm going to add 3y to both sides. Three y's on this side will cancel themselves out, leaving 3x equals 18 plus 3y. The reason why I use this one is when I divide by 3, because I want to get x by itself, both of these are divisible by 3, so it makes it a bit easier on myself. So I'm going to divide by 3, and we get x equals 6 plus y. Okay, so we can take this top equation, 2 times 6 plus y plus 3y equals 12, and we'll be able to solve for y now. Okay, so 2 times 6 is going to be 12, plus 2 times y is 2y, plus 3y equals 12. Okay, so if we combine the y's, we get 12 plus 5y equals 12. We subtract 12. These 12 cancel. 12 minus 12 is 0. So 5y equals 0. Divide by 5. And we get y equals 0. Now we can solve for x by just taking this x equation here. We can say x equals 6 plus 0. So x equals 6. And our solution is 6, 0. Just like the same solution we got from elimination, just a different technique for finding it. Last technique we have is to do some graphing. So let's go out of full screen mode here. And let me open up another tab and I'll search for the Desmos graphing calculator. I'm going to spawn that off here and just do this like this. And so what we're going to do now is we will type in both equations here. So 2x plus 3y equals 12 and 3x minus 3y equals 18. Okay, and we see this point of intersection here is the point 60, which is the solution we got from the other two methods. So the last method using modern tools is the fastest. Used to have to be able to plot it on paper, but now that the SAT allows the use of Desmos, if I were going to find a solution to a system of linear equations, what I would do is I would use Desmos. Hopefully this video has been helpful to you. If it was, please give it a like and consider subscribing to the channel. Thanks for watching. Hope to see you in the next one. Bye.